return and the periodic return, let's look at a few of these other things. The idea here, this is from Professor Hall's slides. GM made some moves over the time period, and we have some quarterly returns based on those price moves, and therefore we can calculate the total holding period return, we can calculate the per quarter period return, and we can also calculate the per year return. And this happens all the time for a variety of stocks. Everyone does this in different situations where they want to figure out what a stock or a mutual fund or a bond or whatever would do during certain periods. So you get all the returns, you figure out what you would have at the end versus what you had at the beginning, you figure out the holding period return, and from there you can calculate the periodic returns. Okay, so let's talk arithmetic mean. We have the arithmetic mean, which is an average of past returns. And let me just show you this. So this is the example that I used in the past lecture. Let me just copy these to another part of the sheet. And actually, oh, dang it, I was going to transpose them. There's an easier way to do that, but that's all right. The arithmetic return is just the average of all these returns. 4%. It's not going to be the 4.15 here. It's a little bit different, and that's just because it is not calculated the same way. Arithmetic mean. I guess I can move it right here. Okay, so what does this tell us? This is an easy way of saying the average return for the past 5 years is 4.2%. It is not the mathematically correct way of saying it, but a lot of people use things that are mathematically incorrect because it's easier, and it's a rule of thumb, and it helps us make quick and easy decisions about how to think about different returns. And so the arithmetic mean, like generally what people do is they'll say, well, the average return for the past 20 years was 7%. That doesn't mean that it was actually 7% if you compounded it. If you took $1 and you multiplied it by 7% every year for 20 years, you would not get the same answer. It just means that on average, when you take the numbers and you do this little calculation where you average them, it's 7%. Now, it requires independence, and that means that the returns aren't related to one another. That is another problem with this measure, because if you think about what's been happening in the stock market the last few days, we rocket up and we rocket back down, and it's all related to what's going on in the economy and the fact that there's a virus out and things are really scary for people. So stock market returns are not independent. And to say that the arithmetic mean is mathematically correct because the observations are independent is not true. The observations are very much dependent on each other. What happened yesterday in the market, especially in this climate, influences what happens today. So the arithmetic mean is not going to be perfect, but people use it because it's really easy to calculate. All you have to do is average it. So a lot of times what people do is to use it to estimate future returns. Well, if on average we made 7%, it's not going to be perfect, but it'll get us reasonably close as long as like really weird stuff doesn't happen, which is exactly what's happening in the market probably today as you're watching this video. One more thing before we stop, geometric mean. The geometric mean is exactly kind of what we did before. So if we did equals 1 plus that, let me put this back in number terms. You can use product. And notice that it will give you the same $1.2256 that we did before. So this is the geometric sum. And then on this formula, when we pull it to the power of number of periods over 1 equals that to the power of 1/5 minus 1. This is the geometric mean. Notice that it is the same as the periodic return, and that this is the same as the total holding period return. Obviously, we need to subtract 1 to get it, but the thing to note here is we have raw percents here. We had to add a 1 and multiply them all together to get the geometric sum. And then we had to make sure that we added 1 before we raise it to the power of 1 over 5 in order to get the geometric mean. If you don't do that, you'll get a weird answer and it won't be right.